All right, so first problem we're going to do. Again, a lot of these problems have the same form, so I'll have a template. So find the surface area obtained by rotating y equals square root of 1 plus e to the x from 0 less than or equal to x less than or equal to 1 about the x-axis. Oof. Okay, so this is our sort of just the standard canonical type of problem. I haven't done anything. It's just who knows how crazy this is going to be. But let's see. So let's take y prime. Y prime. Remember, anytime you have a square root, it's going to be 1 over 2 square root times the derivative of what's in the square root. Okay, so let's write that as e to the x over 2 square roots of 1 plus e to the x. So that's y prime. Okay, so we're going to do, remember, our formula is we're going to take 2 pi, the integral from 0 to 1, f of x, square root of 1 plus f prime squared dx equals, in this case, okay, f of x is square root of 1 plus e to the x times square root of, let me move this down, 1 plus, now we're going to square this. So when we square that, that's going to be e to the 2x over 4, 1 plus e to the x. That looks nasty, doesn't it? But we got this here, we got this here. One thing you have to realize is that with these problems, they're sort of cooked to work in a certain way, all right? So we're going to get 1 plus e to the x plus e to the 2x over 4. Okay, what happened? 1 plus e to the x times 1, that's here. 1 plus e to the x, sorry, times 1, that's here. 1 plus e to the x times this, well, this cancels with this, and we're left with this. That looks like a perfect square to me, doesn't it? It is. It's 1 plus e to the x over 2 squared. Okay. 1 squared is 1. E to the x over 2 squared is e to the 2x over 4. And then e to the x over 2 times 2 is e to the x. At this point, I trust that you should all be able to calculate that. Okay? All right, let's go ahead and do another, or set up another. Make this a little smaller so that we have room. Ta-da. Move this. Okay. We're going to do y equals 1 minus x squared from 0 to 1. This time we're going to do it about the y-axis. What the heck? Okay, now I did not draw this one. I probably should have, if I'm being perfectly honest. So let's do that now, except for, 1 plus e to the x, the square root of that, I don't really know what it looks like. Okay, but let's pretend 0, when it's 0, it's going to be square root of 2. When it's 1, it's going to be square root of 1 plus e. It's doing something like that, let's say. Okay. Reason I wanted to draw it was because I should draw these, just in general. Okay, let's draw the next one. Now this is y equals 1 minus x squared. That's a parabola facing down. Okay, x goes from 0 to 1. So we're actually just going from here to here. But now we're doing it about the y-axis, so we're going to rotate it about this way. Okay, so the integral's a little different. Okay, we're going to set the integral up. We can still do the integral in x. Okay, even though we're doing, we've changed the orientation of the problem. It's one of the nice things about these problems. So from 0 to 1. Now instead of 2 pi, where was it? 2 pi f of x, it's going to be 2 pi x ds. And ds is still this 1 plus f prime squared. What is f prime? F prime of x is just negative 2x. Okay, so we're going to have 2 pi integral from 0 to 1 x square root of 1 plus 4x squared dx. Okay, and then this one you can do a substitution 1 plus 4x squared. And from there, your du is going to be 8x dx. So it's going to be a standard, pretty easy to calculate integral. Don't think that just because I'm doing videos that you're getting shortchanged. In class, I wouldn't do it either. Okay, back when I taught, when I've taught this live, I would leave it there too. Okay, why? Because you guys are Calc 2 students. You should get some practice doing a little bit of integration still. All right, I'll see you on the next video.